Hello Algebra 2 students, this is a help video for the 1.12 unit test part 2, and I'm just going to talk a little bit through each one of these three problems. Number one is giving us some information about Suzette, that she ran and biked for a total of 34 miles, and she did that in 3.5 hours. It says her average running speed was 6 miles per hour and her average biking speed was 12.5 hours. They are telling you to let X be the hours that Suzette ran and Y be the hours that she biked. And then it says use substitution to solve for X or Y, show your work, check your solution. So in this problem, I would work it as a system of equations, and there's enough information in the first two sentences. With Suzette ran and biked a total of 34 miles in 3.5 hours, and with her average running speed being 6 miles per hour and her biking speed being 12.5 miles per hour. That's enough information for you to write two equations. Remember, X is going to be the total hours that Suzette ran, and Y is going to be the total hours that Suzette biked. So you're going to start by writing a system of equations, so two equations, both including X and Y. And then you're going to use the substitution method. Remember, we had substitution and elimination. They're asking you to use the substitution method and show your work. One of the things that I would suggest on probably all of your TGAs is when you're solving and showing your work, it might be easier, instead of typing, to actually just write your work out on a piece of paper, take a picture of your work, email it to yourself, save it on your computer, and then upload it to the Dropbox for the assignment. It's going to be pretty hard to type everything out. I'm not saying that it's impossible to type this problem out, but if you're having to write two equations and you're having to show your work by substitution, it might be easier for you just to write your answers. Take a picture, show your work with your pencil instead of typing everything. Totally up to you, but you do have to show work to get full credit. A is going to be, you're going to write A, and you're going to tell me how many hours Suzette ran, and then B, you're going to tell me how many hours Suzette biked. So you do have to have a system of equations, and then you do have to solve by substitution, and you do have to show your work, and then it says check your solution. You don't really have to show your check. I'm not going to be picky about that, but you would want to make sure that your answers make sense, okay? But you do need to show your work, that your substitution work, show how you got X and Y, and then if you want to check your solutions, that's up to you. So that's number one. Number two is a little bit easier, in my personal opinion. They're giving you the problem. It's not a word problem. You don't have to come up with the equation or the inequality. And number two, they're giving you a single variable inequality, so this is not a system. So to me, number one's a little bit harder because it's two equations, two variables. Number two is just solve the inequality, show your work. So you're solving for only the variable X. It's the only variable in the inequality. Just be really careful with that -5/2. You'll just solve that inequality. Remember, if you ever divide or multiply both sides of an inequality by a negative number, your sign does flip. But compared to number one, number two is a little bit easier. So that's about all all the advice I can give for number two is just be careful as you go through your steps, your solving steps. Number three is probably the hardest problem out of these three. This is coming from section 1.09. So I'll jot that down. So if you're really struggling with this, you might want to go back to 109 in your OHS. This is linear programming. I think this problem is the hardest out of the three. I think number three is the hardest, two is the next hardest, and three is the most difficult, one comes next as in difficulty order, and then number two is the easiest. So on this problem, you're going to have to come up with what your two variables stand for. Okay, I will kind of get you started here. So I would suggest that X be the number of, I think I let my X be the number of video games. software. I did it in order as it comes in the problem. I let X, I want to help you out a little bit more on this one. I let X be the number of software programs the company could produce. I just went in order. It really doesn't matter what you let X or Y be. It just makes more sense for me to go from left to right as it tells us in the problem. So I'll let X be the number of software programs that the company could produce. And I'll let Y be the number of video games that the company can produce. And then you have to read through here very, very carefully. And you're going to set up inequalities based on the information that's here. Okay? So it says a company can profit $50. That's going to be important. Per software program, they can profit $35 per video game. So you'll have an inequality that's got, that's going to be your profit. Let me back up here. This is going to be your profit equation. This is not going to be an inequality. Hold on just a second. Let me find there we go. This statement right here, so for linear programming, we have an equation that we either want to maximize or minimize. So this is going to be your P equation. This is going to be your profit. So you're going to use this information, $50 per software program, $35 per video program. X is the number of software programs that the company can produce. Y is the number of video games. And you'll start by making your profit equation. This is going to be the only equation in this problem. The rest of the problems are going to be inequalities. But you'll take this sentence and you'll make your profit equation. So I'm not going to go any further except this first sentence. I'm not going to tell you any more than that first sentence is going to give you your profit equation. This is going to be the equation that you're going to either maximize or minimize. Find the maximum or the minimum. And if you'll look right here, when you get to the last sentence, it's asking you for the maximum. Okay, it's asking you to maximize the profit. The rest of this problem is going to give you your inequalities. So you're going to set up based on this, the rest of this problem, the company can produce at most, that's a phrase for an inequality, 200 software programs. That's going to produce an inequality. At the most 300 video games. That's going to produce your second inequality. And then it says the total production cannot exceed 425 items per week. That's going to produce your third inequality. So you're going to end up with 3 inequalities. I am going to tell you that you do need to, it's just going to, two inequalities that you'll add. So this piece of the information, so starting here, going to here, is going to produce 3 inequalities. Why can't I draw today? Because it's 5 o'clock. Actually, it's 5:10. So, from here all the way to here. That's going to produce 3 inequalities. That's going to give you 3 inequalities. And I would use Desmos for this. I'm going to remind you that there are 2 more. And that is that the number of software programs has to be positive. So they're not going to tell you this. This is just understood. So X would have to be greater than or equal to 0. And the number of video games produced would also have to be positive. So that's going to give you 5 total inequalities. So in the problem, you're going to get 3 inequalities, and then you're just going to have to know that you can't have any negatives. So I would use Desmos. So I would put all these problems in Desmos, and then you have to find your feasible region. If you've done section 1.09, I also did a lesson on this. in class when I went over 108 and 109. I actually did 2 examples from section 1.09. You could go back and look at that lesson for some more instruction, or you could go back to the OHS. You'll have to do Desmos. Then Desmos is going to produce your feasible region. So let's just say your feasible region looks something like this. And then remember, this is where we get the vertices of that feasible region. That's going to give you X and Y values. And then you'll take those X and Y values and you'll put them in your profit equation, this equation right here. And then you're going to look for the highest value because it's asking for you to maximize. And then you're going to go from there to answer the question. Okay, you do have to show your work. So you don't have to show me this Desmos graph, okay, but you would have to show these 4 any vertices that you get from your feasible region. You would have to show me those 4 ordered pairs, and then you would have to give me what your profit would be for each one of those, and then tell me what the maximum profit is. So definitely number 3 is going to be the hardest out of those 3 problems from your teacher graded assignment. If you have any other questions, please let me know. If you're still needing a little bit of help after submitting and getting some feedback a couple times, remember you can submit your TGAs an infinite number of times up until the end of the quarter and just continue to get that feedback and make changes to hopefully raise your grade to where you want it to be. All right, hopefully this was helpful. See ya.